Question 1, we've got the u term here, which is x plus 3, so we'll substitute that in. So we've got 12u to the 5 dx. We need to replace the dx with a du equivalent, so we'll differentiate our u term. So we'll have du by dx equals, well, it'll just end up being 1. So if we rearrange this, it'll be du equals dx. We can substitute this in now, so we'll have the integral of 12u to the 5 du. We can nicely integrate this now, so we'll have equals 12u to the 6 over 6 plus c, which just simplifies down to 2u to the 6 plus c. We can now substitute in our u value, so we'll have 2 lots of x plus 3 to the 6 plus c. Second question, well, our u value is x squared plus 4, so we'll have the integral of 24x u cubed dx. We need to replace our dx value now, so to do that we need to differentiate this first. So we'll have du by dx, which equals 2x. We can rearrange that, so it'll become du over 2x equals dx. We can substitute in this now into here. So we'll have integral of 24x u cubed times by 1 over 2x du. Tidying this up a bit will give us the integral of 24x u cubed over 2x with respect to u. And that will simplify down nicely to 6u cubed with respect to u. We can integrate this now, which will nicely become 6u to the 4 over 4 plus c. We can simplify this a little bit more to 3 over 2u to the 4 plus c. Then substitute our u value back in, so we'll have 3 over 2 lots of x squared plus 4 to the power 4 plus c. Question 3, we've got equals the integral of 6x square root of u with respect to x, which is the same as saying 6x u to the half with respect to x. We need to replace this dx now, so we'll have du by dx, which equals 2x. Rearrange that, so we'll have du over 2x equals dx. Substitute that in, and we'll have equals the integral of 6x u to the half all over 2x du. Simplify that down, and we'll have the integral of 3u to the half du. Integrate that now, so that will give us 3u to the 3 over 2 over 3 over 2 plus c, which equals 6u to the 3 over 2 over 3 plus c, which equals 2u to the 3 over 2 plus c. Substitute in our u value again, and that will give us our final answer of 2x squared plus 1 to the 3 over 2 plus c. The question 3 challenge one I'm not going to go through, but it's on screen for you now. Question 4 is a bit trickier, but same as always, equals the integral of u to the 5 cos of x with respect to x. We need to replace that dx now, so we need to differentiate this du term, so we'll have du over dx, which equals cos x. Rearrange that now, so we'll have du over cos x equals dx. We can substitute that in now, so we'll have equals the integral of u to the 5 cos x all over cos x with respect to u. That can simplify down to u to the 5 with respect to u. We can integrate this really nicely now, so that'll be u to the 6 over 6 plus c. And finally substitute in our u value back in, so it equals sine to the 6x over 6 plus c. Question 5, we've got the integral of 15u to the 4 over x dx. We need to differentiate this now, so we'll have du over dx, which equals 1 over x. Rearrange this, and we'll have x du equals dx. Substitute that in, so we'll have equals 15 u to the 4 x over x with respect to u. That's the integral. X and x cancel out now, so we'll be left with the integral of 15 u to the 4 du. I'm going to take out that constant factor of 15, so we've got 15 integral u to the 4, just to make it a little bit nicer to integrate. Now we can integrate it, so we've got 15 lots of u5 over 5 plus c. Substitute back in our u value, so we'll have 15 lots of ln x to the 5 all over 5 plus c. That will give us a final answer of 3 ln x to the 5 plus c. And the reason for this 3 is 15 divided by 5 equals 3. Part 2 questions now. We've got the integral of 4x over root u, or to make it a bit nicer, u to the half dx, or with respect to x. We need to replace this dx term, so to do that we need to differentiate this u term, so du by dx equals 2, which is quite nice. Rearranging this, and we'll have du over 2 equals dx. So what we need to do is replace this dx term with this one, and that will give us equals the integral of 4x over 2u to the half with respect to u, because we've times the u through. Next, we need to simplify this down, so we'll have the integral of 2x over u to the half with respect to u. Now we need to replace this x value here, so we'll have to rearrange this u term here. So to do that, we're going to add 1 to both sides, so u plus 1 equals 2x. And we're going to divide both sides by 2, so u plus 1 over 2 equals x. So we've now got our x term, which we can substitute into. So we'll have the integral of 2 lots of u plus 1 over 2 all over u to the half with respect to u. This 2 and then divided by 2 cancel out, so at the top we'll then have equals the integral of u plus 1 over u to the half with respect to u. I'm now going to split up these two terms at the top because this will be easier for integrating. So we'll have equals the integral of u over u to the half plus 1 over u to the half with respect to u. Simplify this a bit more, so we'll have the integral of u to the half plus u to the minus half with respect to u. This is a little nicer to integrate now, so I'll have equals u to the 3 over 2 over 3 over 2 plus u to the half over a half plus c, which can also be written as 2/3, or simplified 2 I should say, u to the 3 over 2 plus 2u to the half plus c. We can substitute in our u value back in, so we'll have equals 2/3 of 2x plus 1, 2x minus 1 to the 3 over 2 plus 2 lots of 2x minus 1 to the half plus c. There's the challenge one fully worked through. I'm not going to go through that one individually. Last but not least, we've got this integral here. So we have the integral of e to the 2x all over u, as the entire bottom has been substituted for u with respect to x. We need to differentiate u now, so we'll have du over dx equals e to the x. Rearrange this, so we'll have du over e to the x equals dx. Substitute in this now into here. So we'll have equals the integral of e to the 2x over u e to the x with respect to u. Well, there's an e to the x that cancels out, so we'll be left with the integral of e to the x over u with respect to u. We need to eliminate this e to the x now, so in order to do that we need to rearrange this u expression here. So what I'm going to do is something nice and simple, is take away 1 from both sides, so I'll have u take away 1 equals e to the x. And actually now, we've got an e to the x term, which is here. And this u term can replace it because we've not got any x terms on that side, so we're just going to directly replace that. So we'll have equals the integral of u minus 1 over u du. I'm going to split these two terms up again into individual fractions, so we'll have equals the integral of u over u minus 1 over u with respect to u, which just simplifies nicely to 1 minus 1 over u with respect to u. Integrating this now, we have equals 1 integrates to u minus and 1 over u integrates to ln u. And we've got plus c. So all that we need to do now is substitute back in our u value. So we have equals 1 plus e to the x minus ln 1 plus e to the x plus c. And there's our final answer.